Our program participates in both the VEX and FIRST Robotics competitions. They happen both in the fall and spring, respectively. So because we're right now we're in the fall period, we chose to focus on VEX Robotics. This particular lesson focuses on the building and construction and having our kids prepare their robots in preparation for the Hawaii State VEX Championship that's happening soon. Yeah, the one thing you'll find is I do very little. I'll talk at the beginning of class so that everyone's on the same page. We remind everyone about the upcoming deadlines and what we need to focus on. And then after that, I just let them go. They pretty much are self-directed. One thing that I want to mention, which I think is a key part of why we are successful, is we're limited as far as resources. I don't have teachers' aides. We don't have the kind of support that I think an ideal classroom would have. And so how do we get over those limitations? A big part of our program is that peer mentorship. So we have a lot of veteran students that have been in our program 3-4 years, and you have a first-year kid. And so how does a first-year student figure out what to do? How do they become self-directed? How do they maximize their time, especially for an hour-and-a-half class period? And so we have our other students in there that are modeling what that right behavior is. And so when they see that, and they see that their robots are better, then they know I got a lot of work to do. And I need to, look at what those guys are doing to be successful, and I need to emulate some of that stuff. And so we've created that culture. Primarily, the number one influence is not because of myself or the mentors that come in to help our program, but it's the other students in the classroom that set that tone. And that, to me, is the number one reason why we're successful. So actually, my job primarily focuses on those student leaders. Yeah. And by me focusing and discussing with them what the expectations are, then it filters down to all the other kids. Now, you're not going to always get 100% participation or attentiveness, all the time. But generally speaking, I think for the most part, it happens. And students have their own timetables and how they go about and how they want to manage X amount of time to do a particular project. But in the end, I think when you see all of our teams being successful, and different teams have different people that are unique. They're going to do things their own ways in certain aspects. But in the end, when they all deliver a product that's something that they're proud of and that I'm proud of too as well, I think that's what matters in the end. Well, the students are taking a course called Engineering 1 and Engineering 2. And in those courses, we have a set of standards and benchmarks that we're supposed to achieve, as outlined by the Career Technical Education Department for the state of Hawaii. And so we try to achieve those objectives and those outcomes, primarily focus on these particular standards, primarily which is the engineering design process, where students have to follow this iterative process in order to come up with an idea, a concept, and then be able to work on their project, come up with some solutions, develop a prototype, and then ultimately coming up with a solution that they feel comfortable with in participating in this competition. One of the things that we have all our students do is create an engineering design notebook. And so in that notebook, students basically tell a story and tell us how they got from the concept that they thought of down to the actual robot final product that they built. And so one of my requirements is to have them do daily journal entries where they incorporate some of their self-reflective thoughts. They use CAD software to visualize, to display what it is that they built or that they're trying to build. They have data, could be graphs, some kind of data table that demonstrates what kind of testing they've done. So ultimately, they have to have a portfolio that demonstrates what they've learned. Now, in addition to that, students participate in local competitions throughout the entire semester. And so after each tournament, our students come back to school and they self-reflect on what the good things were, what things didn't go so well. They talk about some of the challenges that they had that they didn't expect, and work to minimize those things and make their robot better for the next event. So ultimately, the competition serves as a formative assessment in working towards their ultimate goal in performing the best that they can at the Hawaii State VEX Championships. Well, in this whole overall learning process, the things that I try to get our students to focus on are the general learner outcomes. And the general learner outcomes, there's 6 of them. We focus on 4 of them in particular because that in itself models the culture that we want for our program and how students should behave and how they go about working in teams and working together so that they're able to maximize their abilities as a whole in putting out the best product that they can put out. And so let me just read what some of those things are. Being a self-directed learner, where students don't need a teacher to explain to them every little step. They're able to work on by themselves and figure out what they need to do. Being a community contributor, it's understanding what's essential and what's involved as far as all of them being able to work together. Being an effective communicator, so if they have questions, they should ask those things. They should always ask themselves questions. Why am I doing this? How can I make things better? Asking each other questions so that they feed off each other and working together. And of course, being effective and ethical use of technology. So how do you be self-directed in not only working on your project, but utilizing the technology that's provided in helping you do this project? So ultimately, I think those 4 out of the 6 general learner outcomes helps manage the behavior and the setting and the culture of our classroom. Whenever we have students work on their projects, there's 2 main questions that we always try to keep in mind and have students always ask themselves as they're designing their robots. And one is, how do you maximize that design and that concept that you have to scoring as many points as you can? And so in this year's game, it's called Nothing But Net, where robots have to shoot these balls into this net in a 2-minute time period. So how do you maximize that? Is there ways that they can improve what they have currently after doing a competition? How can you improve on that? If you made 30 shots in one match, how can you make it 40 the next time? I mean, you have over 100 balls on the field. To me, if you still have some left over, there's always room for improvement. Well, I think building robots in itself is something that is engaging for kids. It's hands-on. It's in the area of their interest of STEM. They're able to compete in competitions. They participate in interviews with judges to explain what they've learned, what they've done, what they came up with. So beyond the classroom, there's a lot of opportunities for them to showcase what they've learned, and I think that in itself helps or lends itself to engaging students as a whole. Well, all of our students took this class because they're interested in some type of STEM-related career post-high school. And so we feel that this program does bring out, or it does allow our students to pursue and learn specific activities that will help them work towards those STEM career goals.